Here we have a uniform rod and it's resting on these two pegs, not on the ground. So I'm not going to draw a reaction at Y, but I will have two normal reactions. We usually use N for pegs. So I'll call this NP, and the second one here, which I'm going to call NQ. You haven't been told that they are smooth pegs, so I'm going to also draw friction. I'd imagine that this would tend to slip downwards because it's at that slanted angle. So I'm going to call them FP and FQ, and they're going to point upwards. I've also got the weight of the rod, and because it's uniform, then it would be acting at 0.45 from each end. So 0.45 there and 0.45 there. I've changed everything to meters. Okay, it says calculate the normal components. So calculate NP and NQ. Now, because they're already perpendicular, I think it makes sense to take moments from one of the ends. And I'm going to take moments from Y. So I'll have 0.3 times NQ, and that would go clockwise. Add 0.7 times NP equals, now because the weight force is not already perpendicular, I have to find the perpendicular distance of it from the end. So if I think about this, do you remember we always sort of make a right angle triangle? And the angle theta I'll put here is 30 degrees. So this would be the perpendicular distance. And that triangle has 0.45 as the hypotenuse. So it'd be 0.45 cos 30. Times the force, which is 20. And that would go anti-clockwise because the arrow is going the other way. Okay, so let's simplify this equation. I've got, if I know that 0.45 cos 30 times 20 is just 9 root 3 over 2, then I've got 0.3 q plus 0.7 NP equals 9 root 3 over 2. And I'll also times it by 10 just to make it easier because it'll get rid of the decimals on the left. So I'll have 3NQ plus 7NP equals 45 root 3. That's my equation 1. And you know that when you're solving simultaneous equations, you need another one that links NP and NQ. So how am I going to get that? Well, what I could do is resolve perpendicular to the rod. So I have NP plus NQ equals, this force needs to be resolved because it's not currently all perpendicular, it's at an angle. Now this angle here would be 60, so that would make this angle here 30. So this component of the force has to be 20 cos 30. Okay, so that would equal 20 cos 30, which I know is 10 root 3. Okay, because cos 30 is root 3 over 2. So if I rearrange this one, I've got NP equals 10 root 3 minus NQ. And the reason I've done that is because I want to sub into 1 and solve. So my equation 1 will now look like this. 3NQ plus 7 times NP equals 45 root 3. Now we've got to multiply out the bracket and just rearrange this a little bit. So we're going to get 3nq plus 70 root 3 minus 7nq is 45 root 3. Put everything together. We've got 4nq, moving the root 3's to the other side. And then that gives me nq equals 25 root 3 over 4. Okay, which, if you work out on the calculator, is around 10.8 newtons. So you've got to sub back in to get MP. Sub back into here. And you get MP equals 10 root 3, take away this. So that's 40 root 3 over 4, take away this, which is 15 root 3 over 4. And that's approximately 6.5. Okay, so that's part A done. Now, part B says, the coefficient of friction between the rod and each peg is mu. It's about to slip. So the fact that it's about to slip means that I'm going to have Fp equals mu NP, and also Fq equals mu NQ. So let's resolve parallel to the rod this time. So that would give me go back up to the diagram. You can see the Fp and the Fq are pointing upwards, and then you've also got this parallel, okay, which is 20 sine 30. So those two added together are going to equal 20 sine 30. And we know that sine 30 is a half. So that's going to equal 10. Now what we can do is put our values for NP and NQ in and take mu out in a bracket. So we have 15 root 3 over 4, add 25 root 3 over 4 equals 10. And put these two together, 40 root 3 over 4, which is 10 root 3. And then when you divide over, you get 1 over root 3 because the 10s cancel. So that's your value for the coefficient of friction.